Are y'all even watching these videos? I don't even know. Like, I'm getting questions left and right about stuff that I'm clearly saying in these videos. So that leads me to believe that y'all aren't watching these videos. I understand me learning from videos, firsthand experience. They sometimes don't answer some of my questions, or I need a clarification by talking to the instructor. So for those of you that have reached out to me just because you had secondary questions, that's fine. But I'm not talking about y'all. I'm talking about as soon as messaging me saying like 1-arm ratios. I'm like, you didn't watch the video, did you? This is the test run right here, whether you guys are watching this. Send me an inbox message or a text message saying rabbits and bunnies. I won't even respond to it. But by sending me that inbox message through Canvas or a text message or email saying just rabbits and bunnies, I'd be like, this person saw this video right here in the middle of math lessons. During percent proportions, they saw the video. So I'll probably give you extra credit, even though there's no credits involved with the GD. Alrighty, my friends, let's get started with percent proportions. Percent proportions is almost an exact replica, if not the exact replica of proportions. So please watch the video prior to this to get down proportions. There's only one difference, is that we're, in this example, incorporating percents now. The first part of this worksheet that you're going to do after this video is just identifying something called the part, the base, and the rate. This is essential to understand percent proportions. But all you're doing is identifying. You're just writing out the number that represents your part, base, and rate from that word problem. Then after that section, you're actually going to do just like what you did in proportions, in the proportion worksheets, which is solving for the missing number. Let's look at this first example as to identifying part, base, and rate. So, and yes, of course, I'm going to explain what that is, part, base, and rate. Let's look at this example. At a restaurant, Janice's bill is $20. She gives the waiter a tip of $3, which is 15% of her bill. Identify the base, part, and rate in this situation. So, what are we doing here? Well, like I said, part, base, and rate. Your first lesson of the day. So knowing what each of them means. So I'll start with the easy one. The rate, my friend, is always going to be your percent. If you are given a question, and there are many different types of percent questions out there, right? But if they give you a question like this, and you know it's similar to proportions, they want you to find the missing number of some sorts, but you're given a percent instead of just a normal number. That should be an indicator that you're dealing with a percent proportion. And what you got to understand is that that percent that you see in that word problem will always be your rate. All right. The part and the base. This one's easy. The base, think of it as the total. Okay. Total. The part, think of it as your piece. Your piece de resistance. So let's just look at it in this specific example. At a restaurant, Janice's bill is $20. The bill was $20. What do you think that 20 is? Is it the part? Is that the base? Is that the rate? That's the base, my friend. The base is the $20. Because that's the total amount. In this situation, the total amount of the bill. Obviously, every word problem is different, right? But you're looking for that total amount. That's your base. She gives the waiter a tip of $3. The tip is $3. $3 is just a little piece from the total amount, right? That is your part. In this specific example, the tip is $3. which is 15% of her bill. Oh, I see the percent right there. I should have known immediately that was going to be the rate. 15. You just identified the base, the part, and the rate. Easy, right? Why is that important? Because of this right here. Our setup. Yeah, just like in the previous video with proportions, percent proportions has its own setup. The setup will always look like this. The part will always be over the base, and the rates will always be over 100. The percent is always over 100. You guys have always heard that phrase before. You can never give more than 100%, right? That's because 100 represents 100. It's just the total amount of the percent. Now, it's true that in some economic classes, mostly in economics and business classes, they definitely go over 100, right? It makes sense. Let's say you created a business and you were only making $5 a week because you were just, a small-time business owner selling lemonades on the side of the street, right? $5 a week. And then I don't know where your lemonades goes viral and like everybody loves it. Next thing you know, you're making $10,000 a week. Your in economics world, your business grew like 600%, right? Like, I don't know, 10,000%. So yes, in business world, you will deal with a lot more over 100, but still in the real world, nothing is technically over 100, which is why the rate was always over that specific number, 100. So there's your template right there of percent proportions. Now you know why we had to master identifying part, base, and rate, because now all you got to do is put it into its designated area, right? Now in this specific case, in this specific example, we had all three. We had the base, we had the part, we had the rate. How will it look like? It'll be 3 over 20 over 50 equals 15 over 100, right? There's no missing variable here. Again, the skills with percent proportions, the first thing you need to master is identifying the part, base, and rate. But then comes those questions of which one of these guys is going to be missing from the word problem, and then you're going to use your skills of proportions to solve it. Let's look at the next example right here. At a plant that manufactures lighting fixtures, it is expected that about 2% of the fixtures assembled each day will have some type of defect. If 900 fixtures are completed in one day, how many are expected to be defective? Okay, there's one missing variable. There's one it's either the part, it's either the base, or it's either the rate. You have to use your skills of identifying the part, base, and rate, see which one it is that you're given, and then use proportions to solve it. So, like I said, we know the template. Part is always going to be over base, and rate will always be over 100. I always tell students, go to the easy one always, the rate. Like I said, the rate is always going to be the percent in the word problem. Were we given a percent, or were we told to find the percent? Because that's also an indicator that the rate would be in that case x over 100. If they're asking you what is the percent, but no, not in this case. They gave me it. It is expected that about 2% of the fixtures assembled each day will have some type of defect. I was given the rate here, folks. I was given the percent. So I already know my rate is 2 over 100. Now it's just a matter of figuring out what other number they gave me. If we continue on, 2% of the fixtures assembled each day will have some type of defect. If 900 fixtures are completed in one day, how many are expected to be defective? Read that question right there. I know 900 is my other number. But now, what does that 900 represent? Is that the part, or is that the base? Remember, the part is the piece, the base is kind of like the total. If you read carefully, if 900 fixtures are completed in one day, that to me, folks, is representing base. If a company makes 900 fixtures in one day, that's the total. And what they're asking for is how many of those 900s is supposed to be defective. That's the piece. They're looking for that missing piece. How many of that 900, 2% of that 900 fixtures, how much will be defective? That's what they want to know. You just did your setup, my friends, and just like proportions, what do you do now? You do your cross multiplication. 900 times 2 is 1800. 1800 divided by your third number. In this specific case, with percent proportions, your third number is always going to be the same number, 100. You end up with 18. 18 fixtures out of 900 will be defective, given this specific situation, with 2% out of the 100 being defective. Pretty straightforward, my friends. The hard part with this lesson is, just like proportions, your setup, doing this little stage right here prior to me finding the answer, and I had to put the variable. This part right here, the setup, is going to be the tough part. That is the hard part, and also identifying your part, base, and rate. Most of you are going to get your part and your base confused. Some of you, when you go to do your setup, you're going to put the 900 above and the X below, just because you didn't really analyze the question very well. So please just focus on your part, base, and rate. Well, the rate is easy. It's always going to be the percent. And always focus on your setup. And then always do the math correctly too. All right, my friends. Hope this was pretty straightforward. This one's an easy one. It's just a kind of a continuation of proportions anyway. So just hit me up if you have any sort of questions that was not answered in the video. I hope you guys enjoyed.